From above, the Sahara appears empty and lifeless. But beneath this desert lies a hidden world of water. This is the Great Man-Made River, one of the largest engineering attempts ever made to move water across a desert.
Libya has one of the driest climates on Earth. Most of its population lives near the Mediterranean coast, while much of its water lies hundreds of kilometers away.
Unlike countries with permanent rivers, Libya had to search beneath the ground for its most valuable resource.
Thousands of years ago, parts of North Africa experienced wetter climates. Rainfall from those periods slowly accumulated underground.
Deep below the Sahara lies the Nubian sandstone aquifer system, containing some of the world's largest fossil groundwater reserves. This water is not a flowing underground river. It is ancient groundwater preserved inside layers of sandstone. For decades, scientists studied these underground reserves and asked a question that seemed almost impossible. Could humans move enough water across hundreds of kilometers of desert to transform an entire country? The answer became the Great Man-Made River. Planning accelerated in the early 1980s, and construction began in 1984. But creating a river without a river required solving problems on an extraordinary scale. As the nation expanded, the coastal cities faced an urgent demand for reliable, sustainable water sources. And
some wells reached more than 500 meters below the surface, searching for water hidden beyond ordinary reach.
The project connected remote southern aquifers with cities, including Tripoli and other coastal communities.
Moving this ancient water was identified as a necessary, long-term strategic priority for the nation's future.
Hundreds of individual wells were linked together, creating an artificial supply chain of life-giving resources. Each site was chosen with extreme precision to ensure long-term stability of the underground pressure.
The infrastructure needed to be robust enough to withstand the unforgiving heat and shifting dunes.
Isolated by hundreds of kilometers of sand, these stations act as the heart of the entire network. Maintaining constant hydraulic pressure across thousands of kilometers is a daily technical battle. Getting materials to these remote sites was the first of many logistical hurdles to overcome. The project demanded an immense workforce, working in the most extreme conditions on Earth. It is a testament to what human persistence can achieve in the face of nature's constraints.
The pipes themselves became an engineering achievement. They had to withstand enormous pressure while surviving decades beneath the desert.
Thousands of kilometers of trenches had to be created across one of Earth's harshest environments. The project demanded an immense workforce, working in the most extreme conditions on Earth.
Burying the pipeline protects it from temperature extremes and surface hazards, ensuring its longevity. Technology monitors every centimeter, ensuring that no leaks occur in this vital artery.
These pumping stations are architectural marvels, designed to handle millions of cubic meters of water daily.
The scale of this pipeline network is unprecedented, spanning roughly 4,000 kilometers in total length. Rigorous inspection protocols are the only way to manage such a complex, massive infrastructure. Construction moved across the Sahara like a rolling wave, conquering the desert kilometer by kilometer. Each segment weighs dozens of tons, requiring specialized transport and handling equipment at every stage.
Human precision remains the backbone of the project, complementing the heavy machinery on the ground.
The project represents a bridge between the ancient water reserves
and the modern needs of society. Every joint is built to withstand the thermal expansion and contraction caused by the desert heat. To support such a massive effort, manufacturing facilities were built locally to supply the vast requirements. Quality control ensures that only the strongest materials are used in the final construction phase. Cleanliness and structural integrity are paramount to the success of the water transport process.
Precision alignment allows the water to flow without turbulence, preserving the energy of the system.
These pumping stations are architectural marvels, designed to handle millions of cubic meters of water daily.
This engineering triumph forever changed how we view water management in arid regions. Inside these massive pipes, controlled pressure moves millions of cubic meters of water every day. And powerful pumping systems maintain the movement of water across enormous distances. Managing such a system requires constant monitoring across thousands of kilometers. The desert itself remains one of the greatest engineering challenges. Advanced sensors provide the data needed to keep the system balanced and secure. And powerful pumping systems maintain the movement of water across enormous distances. The final result is the delivery of water to the people who need it most. Maintenance and calibration are the daily duties of the crews, keeping the system alive. Nature is constantly testing the system, but the design accounts for these environmental stressors.
Safety mechanisms protect the pipeline from potential ruptures or catastrophic pressure drops.
Every valve and pump is part of a delicate balance, maintained by skilled human hands. The network never sleeps, continuing to transfer water from deep underground every single minute. Total oversight of the system allows operators to see the movement of every drop across the nation. Underground access is critical for ensuring the longevity of these buried lifelines. The engineering is subtle, yet the impact is profound and widespread. For millions of people, the great man-made river became a symbol of engineering ambition. But every solution creates new questions. Fossil groundwater is different from renewable water sources. It does not recharge quickly on human timescales. The challenge is no longer only moving water. It is protecting the water that already exists. Large systems require constant investment, monitoring, and protection. The project also became one of the most important symbols of Libya's infrastructure ambitions. However, political instability and conflict created additional challenges for maintaining such a complex network. The future of the system depends on engineering, management, and long-term planning. A pipeline across the desert is not only a structure, it is a relationship between humans and a fragile environment. The desert was never truly empty. It was hiding a resource that changed the course of modern Libya. Behind every drop was decades of science, engineering, and human effort. The great man-made river shows both the power and the limits of human technology. As climate change increases pressure on water resources, similar challenges will appear everywhere. The next great engineering achievements may not be about conquering nature, but understanding how to live with it. The story of water has always been the story of civilization. And around the world, engineers are